position. Going back with all the angles we were doing yesterday, basically here's what it is. And again, we kind of mentioned this yesterday a little bit, but this is basically when an angle has the vertex at the origin and one ray is on the positive x-axis. Okay. And whenever they talk about that ray that's on the positive x-axis, they call that the initial side. Because again, that's the beginning side, so that's why it's there. If you go back to what we're doing with the unit circle yesterday when we were going through it and working through everything, that's when we were saying we had everything on the unit circle. We were doing all the stuff, and we were saying that when we went over here to the right side of it, that was 0, 0 when we were going through this thing. And that's basically kind of what we're doing for this part of it, is that we're saying that for this part of it, for the initial side, it's always going to be this piece that goes from here to here. Okay, so that's always going to be the initial side. So they have to give you that one because what we said yesterday was this is where it started at 0 degrees. Or if we were doing it at radians, it was at 0, 0. So whenever we're talking about initial side, that's what we're talking about initial side. It's this side that goes from here back to here. All right, the other part of it, the other ray that you have is just called the terminal side. Tells you, and terminal meaning is the ending part of it. So this tells you where it ends. So the initial side is where you start. The terminal side is where you're going to end. Okay. And then once they kind of talk about this, they're going to have you sketch angles. And again, it's not going to be anything that you have to draw it. I'm not going to get out of, protractors and different things and try to get it so it's exactly perfect. No, this is just as long as it's in the ballpark kind of a thing. And a lot of these questions, when you're going through the homework, it's probably going to be where they're going to give you multiple choice options and saying, okay, here, pick the one that's a 30-degree angle. And you just have to go back in and find the one that you're going to find. The main thing on this one, though, is that you have two different types of angles. They can either be positive or negative. And we'll say that positive angles are drawn up from the initial side. And negative angles are going to be drawn down from the initial side. Okay, and sketch-wise, it's not very complicated. Again, this is not something that's super elaborate. It's just a basic sketch of what they're going to ask you to do. So we'll show you kind of what they're looking at here. They may tell you to sketch a 60-degree angle. Here we go, something like this. And more than likely, and again, they'll kind of go, some of these they do, some of these they don't, but hopefully most of this, they'll give you an XY axis that's something like this. And then they'll have an angle drawn, and online it should be in color so that it stands out from what you're doing. And again, you'll always have this one side that will be here. So if they don't give you this side that's going from here to here, you can throw that question out. So if it's, 4 choices, if they don't have one that's drawn from the middle to the right side of it going this way, you can toss out those questions when it comes up to it. And then from here, you go up 60 degrees till it's about there. Okay. And they will always have this arrow drawn in between the angles so that you'll know the difference of whether it's positive or negative. If they didn't draw that angle, if they just give you this, you don't have to write this down, I'm just kind of showing you. If all they did was give you this, it's a trick question because you don't know if they wanted this angle to go this way or if they wanted this angle to go this way. So they have to give you an arrow. They have to do some kind of mark, if nothing else, kind of thinking about here, that they have to mark it some way to let you know exactly what angle it is that they're talking about. All right, so let's do a sketch of negative 60 degrees. Okay, so negative 60. Again, still start on the same side of it. So you always have this part of it that will be the same. And the only difference is, again, instead of going up, again, now you're going to go down. So it will look something like that. Okay, so the arrow is the big thing. It tells you, which way it is, and it lets you know if it's going to be positive or negative. Anything positive, it has to go this direction where you're covered here. Anything negative, it's got to be going in that direction. Okay, now they're going to have you mix in some where you're doing it with radians. So you made sketch 3 pi over 2. And this is where you got to have the sheet when we did the unit circle yesterday, because you're probably going to look at that and go, especially in the beginning, you're going to look at that and you go, I don't know what that is. Well, that's when you just take out your unit circle and you go, oh, 3 pi over 2, that's 270 degrees. And it's positive, so you got to go this direction. And so basically you just go until you get back around to where 270 degrees would be. So it would look something like that. And some of these, they may not actually give you the XY axis. So some of them may look just like that, where it's just an arrow for each of the rays of the angle. And then they'll either mark it this way for positive or it will be that way for negative. Okay. And in the beginning, that's probably, once we get to working these for a week or so, it might be easier to graph it. And you may not even have to look only the graph to find out that that was 270. But, if you get stuck on these and you don't know exactly what it is, that's the whole reason of having the unit circle, is that if you get something that's 5 pi over 6 and you're like, I don't know what that is, well, then you just look on here and go, oh, well, that's the same thing as 150. So just keep the unit circle out, keep it going. That way it's handy. It's always there with you to kind of work through it. All right, let's do one more sketch. Do negative 5 pi over 4. All right, again, if you're not sure which one that is, 5 pi over 4 is 225, so basically we're sketching negative 225. Okay, and if they happen to not give you the XY axis, again, the one thing that will always be the same is you've got to have this one that's coming off the right side of it. And again, if it's negative, you have to go in this direction. So that would be 90 if you went to here. 180 would get you to here. All the way back to here would be 270, so it's going to be a little bit short of 270. Should be somewhere in this ballpark. Okay, and again, you don't have to get exact. Even when you're looking at these, it's multiple choice online. They may not be exactly drawn. They should be ballpark. So there shouldn't be any of them that are. They won't give you 2 questions. It's really close and a trick question. So if they give you options on these, it'll be really obvious as to which one it is that you're looking at. Okay, so sketching angles. That's about all that you have to have with it. Now, here's where they kind of tie in with this one, because, again, if they didn't give you any arrows on this one, if they just gave you this angle and there was no arrows, you wouldn't know which way it was, because you could either go that way or you could wind up that way to get up at the same location. So if when they talk about this one and what we're doing, this is kind of where they go with the next part of it, is they're going to talk about coterminal angles. And basically is this, coterminal angles, these are angles that share the same terminal ray, which just basically means they end at the same spot. If you want to put it in just regular terms. Sometimes a lot of times you get the math definitions, you're like, okay, what does that mean? So when it says it's angles that share the same terminal ray, that just means that they end at the same spot. So this would be an example of two things that's coterminal. You've got the negative 225 that's here. You've got the other angle that's going here. And then some people are like, well, and sometimes they'll tell you, all right, fine, they'll give this angle. Tell me what the angle would be that's coterminal with that angle. And sometimes people are like, okay, well, how do we do that? Well, here's the easy thing to do this. So to find a coterminal angle, and we'll do this one first since it's right here, of a negative angle, you do one easy little thing. You just add 360. And to find a coterminal angle of a positive angle, anybody want to take a wild guess? Yeah, just subtract 360. So if it's negative, you add 360. If it's positive, then you subtract 360. Okay, and again, that would basically kind of get you what we had up here. So with this drawing that we had up here, that was negative 225, if we want to know what this angle was that was here, we'll do it next here. So we had negative 225. So if we kind of go with what we had back up here, we were given negative 225, find the coterminal angle. Well, to find out what that angle was, if this was the negative 225, to find this angle that was over here, again, you just take it and add 360 to it. There you go. So it's 135 degrees. Okay, and that's it. That's all you have to do with the numbers when you go through this one. So just give you another one here. So if this was example 1, call it that way. Let's give you one that was like 450 degrees. It's positive. So just subtract 360. So that would be 90. Okay. And now, occasionally on some of these, they may talk about finding a coterminal angle, and they'll give you some restrictions on this one. So they might do something like this, where they may say find a coterminal angle that is between 0 degrees and 360 degrees. So they may start you off with something like negative 280. And you may go, well, that doesn't really look a whole lot different than what we did before. We're just going to add 360 to it, right? Yeah, just add 360 to it. So we do negative 280 plus 360. Check it. That comes out to be 80 degrees. So it's between 0 and 360. Okay. Now, where this one really kind of comes in, where they put that number on it with the restrictions between 0 and 360 is if they give you one that's like this. Maybe it's negative 560 degrees. So still do the same thing. You add 360 to it. But when you add 360 to it, your answer is still negative. So it's negative 200. Okay, that's not between 0 and 360. So if it's not big enough, well, just add another 360. So if you add 360 to the number and it's still not between 0 and 360, you just add another 360 to it. If you did that and the number still wasn't between 0 and 360, then you just add another 360. So you just keep adding 360 until the number's big enough that it gets you where it needs to be. Same thing if it was, some big positive number. Let's say it was 800 degrees. Well, it's a positive number, so you subtract 360. That's what, like 440? Still not between 0 and 360, so then you would just subtract 360 again. And then finally, the second time you get it, so it's between 0 and 360. So, still the same thing. You just add 360 until you get there, or you subtract 360 until you get to between those two numbers. All right. The only thing that might happen, and I don't think this will happen, but just in case, we'll throw this one out here to you. It may be that for the last one that we'll do here, it might be that they may give you a number that is in radians. And if they do that, we'll show you both. We'll give you one that's a radian answer and one that's also a degree answer. So for this one, we've got negative 11 pi over 6. Again, you're more likely going to have to go back to your unit circle and you go, all right, well, 11 pi over 6 is 330. So if it's negative 11 pi over 6, then that basically means that this would be the same thing as negative 330. So then you may look at it and go, okay, well, that's a negative number. I need to add 360. All right, so we do that. That is 30 degrees. Okay, now they might, if it's one like this where they start with radians, they may not let you give the answer in degrees. They may say, all right, you need to write this answer in radian form. And that's usually when people go, oh, what do I do? Well, same thing. Now go backwards. 30 degrees is here. That's the same thing as pi over 6. So then we can just take that 30 degree angle we've got, write it in radians. That would make it pi over 6. So, but more than likely, if they give you an answer in radians to start with, they probably want the answer in radians when you get finished with it. If they start with degrees, then you stay in degrees. I don't know that you'll see this, but just to be on the safe side in case they sneak this one in on you, that's kind of what you would do. Okay, now here's the other thing that you could do, and this is that's the end of section 2. Here's where we'll go to 13.3, because 13.3 says, all right, well, what if, and somebody may be thinking this one, if you were, you're right on track where we're going next. Somebody may be saying, all right, well, that's great, but what if they gave us like 80 degrees or 40 degrees, where it's not a number that's on the unit circle? What do we do then? Well, here's what we do. So this would basically be for angles that's not on the unit circle. I don't know that's really what they call it in the book when we're going through these, but that's pretty much what we're doing on this one, is that these are angles that's not on the unit circle that we have to kind of go through on this one. So here's what we're going to do. They may tell you to convert it from degrees to radians. And I always tell people that, this is what you want to do if it's not on the unit circle, because if it's on the unit circle, obviously you just go back and you look at it and go, oh, 5 pi over 6, that's 150. Or, if it's 120, that's the same thing as 2 pi over 3. But 13.3 really keys on, all right, what happens when you have an angle that's not on the unit circle? What do we do then? Okay, so here's what we're going to do. And it's really two easy little things. You're going to multiply whatever the degrees are by pi over 180. And then once you do that, there's only one other thing you have to do, and that is simplify the fraction. Now, of the two things we have to do today, this is the toughest one of the two. And it's really not that bad, especially if you've got a calculator and you can go, and some people tell me, I'm not good at simplifying fractions. Well, if you've got a calculator, go back and let it help you kind of go through that. Most of these fractions that you're going to simplify won't really be that hard. There might be an occasional one they might sneak in on you that might be, but most of these fractions should be pretty straightforward. Okay, so let's go with 40 degrees. Again, it's close, but not quite there when we go through this one. So if it's not on the unit circle, we're going to take that number 40 and we're going to multiply it by pi over 180. And if you want to, you can just make it like one big fraction. So it's like that. And for the simplifying, if they end in 0, it's really easy because you can knock out the zeros. Make it 4 pi over 18. They're both even, so you can divide them both by 2. So that would make it 2 pi over 9. All right. If it happens to be a negative number, don't let the negatives. Sometimes people get thrown off by the negatives. Basically, you would just pretend like it was just like it was up here. You could go ahead and do the number. The only difference is at the end, your answer is going to be negative. Just like this was negative 40. At the end, you just go back and make this negative 2 pi over 9. So the negative doesn't really do anything at all to it because it's still the same setup on this part. So it's still negative 50 times pi divided by 180. Zeros will cancel. So it's negative 5 pi over 18. And then people go, all right, well, it's easy if the end's in 0. Yeah, so let's give you one that does end in 0. Let's dig our way through it so you can kind of see what happens if it's something that ends in, 2 or 4. Might even end in a 3, possibly, depending on the numbers. There's only so many numbers they can pick on these because if they pick some weird numbers, like the ends in a 7, like it's 37 over 180 or, 47 over 180 or 40, some numbers just won't simplify. So they'll have to kind of get some numbers options out there that are fairly easy to simplify. So let's go with negative 222 degrees. Okay, so that's negative 222 pi over 180. And you can do this in a couple of different ways. If you look at some of these and you're like, well, I'm not sure of the numbers, you can either just divide out what you know, or you can also just kind of use your calculator to kind of check on these a little bit. That if you've got something like this, and you're like, well, I know that they're both even, so I can just start checking the even numbers. We know we can divide it by 2, but you're like, okay, what if I could divide it by 4? Well, if we divide 222 by 4, that makes it 55.5. So 4 is not going to work. Maybe try 6. Well, that comes out to be 37. So we'll hang on that one. And if you do 180 divided by 6, well, that's 30. So we can make this negative 37 pi over 30. And then if you check that one, 37, there's not really anything that goes into 37 because it's a prime number. If you start going through all the list of numbers, that's it. So for that one, that's as far as you have to go. You do not have to make these into a mixed number. As long as it's simplified as much as you can simplify it, that's fine to leave it in proper fractions. Absolutely. Don't worry about changing these into mixed numbers because you do not have to. As long as it's simplified, because some people are like, what if I divided this by 2? Well, that would have left you with negative 111 pi over 90. You would have had to recognize that you could have then divided them both by 3, which would have then have gotten you to 37 over 30. So, if you start off dividing it by 2 to get it to here, you've got to recognize it. Then you could go back and check it with since it's odd number, you got to go back and check 111 with the 3s and the 5s and the 7s and those kind of things to see if it's going to work. Okay, so worst case scenario, you do have to do a little simplifying. If you're not good at simplifying, there's not a lot of these, so it's just a little bit of practice when you go through this one. The last one that you have to go for this section, going the other way, you're going to convert radians to degrees. And this is the one that everybody likes because this is really, 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 really easy. I mean, if the one before was easy, this is even easier than that when it comes off of it. And there's only one thing to do. And you're going to do the opposite. You're going to multiply by 180 over pi. No simplifying on this one because everything after this, you're just going to use your calculator. All right, so we start off with 9 pi over 5. And we're going to multiply by 180 over pi. All right, here's where my chemistry people get to kick in. Because this, again, if you're doing any kind of conversions, you're trying to cancel things out. You cancel out the pi. So now you're just left with 9 times 180 over 5. And from there, just use your calculator. Just 9 times 180 divided by 5. There you go. It's 324. So if you have a calculator, which pretty much everybody has one now, especially if you've got a smartphone, you've got one in your pocket there, it's all just a calculator question. There's really not a whole lot to it. This is about a worst case scenario problem as you can get. I'll show you another one that might be, and it's not even really a bad situation. It's just not as neat as this one. So we're just going to take negative 7 pi over 13 and multiply it by 180 over pi. And again, the pi's will cancel out. From there, it's just using your calculator. So it's negative 7 times 180 divided by 13. Worst case scenario on this one is it comes out to be a decimal number, and then they should tell you how many decimals to round this thing off to. We'll say for this one, let's go like to 1 decimal place. So this will be like negative 96.9 degrees. And they'll tell you what to round it to in the problem. They'll tell you to go to 1 decimal place or maybe 2 decimal places. They may tell you to go to 3 decimal places, whatever the case may be. They might even tell you to round this off to the nearest whole number. So if it was nearest whole number, it could be that's just negative 97 degrees. So just kind of, just watch the directions. Sometimes it's not always the same. So if you watch one and it's to the 10th place, they may turn around and tell you the next one to round to the nearest whole number. You just have to watch the directions and see what it is they give to you. All right, give me one more of these because this is a trick question. Because this one throws some people off sometimes. You have something like 4.954. Because people go, all right, well, where's the pi? Where's the radian part of it? Well, basically what they did was they took some number, just guessing here, like 1.5 pi, and they said, all right, well, instead of me giving it to you this way, we just went ahead and multiplied this thing out and got this decimal number. So it'd been probably like 1.6 pi, really, I guess is what it was. Don't know exactly what it was. Yeah, not even that. It's somewhere between 1.5 and 1.6. So they gave you some number, and instead of giving you pi and the number, they just went ahead and wrote it out. You still do it the exact same way. You still multiply it by 180, and then you divide it by pi. The only difference is in this case, the pi's don't cancel. You just have to use the pi button on your calculator to figure out what this number is going to be. So it comes out to be 2.83.8. Uh, 283.8 degrees. All right. Somebody always say, well, if I'm using my phone and I'm doing the homework on these, it doesn't have the pi button. Okay. So if it doesn't have the pi button, you're going to have to use, don't just use 3.14. I mean, you can, but probably in this case, if you can go a couple extra decimal places, 3.14, if you can do the 159, that'll give you an answer that should be almost exactly the same. There you go. That was pretty close there. So 2.283.84. I think the other one was somewhere back here. The decimals got off. Sometimes they may even tell you in the answers in the question for these problems that they may tell you, okay, go ahead and use 3.14. So sometimes they'll tell you, don't use the pi button, use 3.14. So that's another one where, again, you've got to watch the directions that if you did it, this case, the answer's off by just a little bit. But they'll tell you what to use in the question when you're going through it. So just watch the directions and they'll tell you exactly what to do when you're going through those. All right. And then the last thing, that this one just didn't really fit anywhere. It was one little topic that was off somewhere else. So we're going to go ahead and put it in here because it sort of kind of fits, but not exactly. To find an intercepted arc, you're just going to multiply two things. You're going to multiply the radius and the angle given. And sometimes on these, they'll talk about it, but then sometimes they give you a formula with this too. And people are like, was that in italics? Oh, no, technically that's theta. They go back and use a Greek alphabet part on this one. Just think about that as just being like a normal variable. That could be like an X or a Y. You can think about it as an O. To me, it always looks like a kid with a baseball cap on. But that's just me. So whenever you see the theta on that one, just realize that really what they're talking about in this case is R is the radius, which is obvious. The theta part, that's what your angle is. If anybody goes into stats, they use alphas and betas a lot when you go into stats. Some different parts of it use different Greek alphabets when they pull in things with it. So, just kind of go with that one. The S is the intercepted arc. I don't know why it's S. It just is. Okay, but this is a really straightforward type question when you see it. Okay, so here's your arc. They're going to give you the angle. And then somewhere along the way, they'll give you what the radius is. And this is 11 centimeters. And then to get the answer, all you do is just multiply these two numbers together. So it's 11 times pi over 2. And in that case, there's not really anything to do other than just multiply the two things together. Okay, and about the worst case scenario you get for one like this. Is maybe something like this. We've got 5 pi over 4 for the angle, and the radius is 8 inches. Still go ahead and multiply those two things together. So it's 5 pi over 4 times 8. Okay. If it's a whole number, if you want to put it over 1, you can do that just so you know exactly where it's going to be. And from there, you just multiply it together. It's 40 pi divided by 4. And then this part kind of looks like when we're doing the conversions back here. Well, all you've got to do then is just go back in. Actually, we've been this one back here. Is just go back through the problem that you have, like we're doing back here, and just simplify this fraction. Well, in that case, it comes out nice because 40 divided by 4 is just 10. So that's 10 pi. Okay, so that's it.